First, we get to make names for all the different numbers on the number line. Anything on the number line is called a real number, and its abbreviation is the capital R with 2 sticks. So basically any single number from negative infinity to positive infinity is on the real number line. If it's not on the real number line, it's going to be imaginary, which is represented with the lowercase I. And an imaginary number is when you have a negative number underneath a square root sign. A negative sign in front of a square root sign is okay, that's real. But if you have something like the square root of negative 4, that's imaginary, it's not on the real number line. So the first set of numbers represented by a capital N for natural numbers, it's the numbers you learn when you're first learning how to count. So like 1, 2, 3, all of those numbers are all positive. Then we got to include the 0. So we start with 0, 1, 2, 3, and so on. Those numbers are called the whole numbers. They are abbreviated with a capital W. And I remember they're the whole numbers because they start with a 0, and the 0 looks like a little hole. Next we have all of the positive numbers, all of the negative numbers, and also 0. So when we add the negative numbers, still no decimals or fractions. These are all just nice numbers with no decimals. These are called the integers. And the symbol for integers is a capital Z. Then we start slicing numbers up. So instead of all these nice numbers, positive or negative or 0, then we divide them. When we divide them, if we get nice decimals, we call them rational numbers. Nice decimals. Nice decimals either stop or they repeat. So a decimal for the fraction 1/2 would be 0.5. That's nice. A decimal for 3/4 is 0.75, so that's nice. The decimal for 1/3 is 0.3 repeating, and so that's rational. Irrational decimals, there's not really a symbol, so we'll say IR. Irrational decimals are crazy, there's no pattern, they never repeat, they never end, and pi is an example of that, 3.14159, and it keeps going. Oops, 3.14. Or the square root of 2. If you type in the square root of 2, you get 1.41, and then it keeps going, and no pattern. So let's use that info to classify these numbers. Negative 5 divided by 2, if we type that in a calculator, it's negative 2.5. So since we have a fraction with a decimal, I'm automatically looking in one of these two sections, rational or irrational. That decimal is 0.5, it's a nice one, so it's a rational number. And the number negative 2.5 can also be found on the number line. It's not an imaginary number, so it's real. Next, the square root of 2, we just talked about that. That's in the irrational section. And it's on the real number line. Even though it's a crazy decimal, it's still part of our real number line. It doesn't have a negative underneath that, so it's real. 0 is not a natural number because all the natural numbers are positive, but 0 is a whole number. It is an integer because it's positive, negative, or 0. And 0 has a nice decimal. It's 0.0, and the nice decimals are rational, and 0 is on the real number line, so it's real. 0.6 repeating, that's a repeating decimal, so it's rational, and it's on the real number line. And 13, 13 is a natural number because it's a positive number. It is a whole number because it's on the list that includes all the positive numbers and 0. It is an integer. It is a rational number because it has a nice decimal, and it's a real number. To order the numbers from least to greatest, I'm first going to just rewrite them as all decimals. So we've already talked about these first two. I know what they are as decimals. Now I can order from least to greatest. So we're going to go from left to right on the number line. So the one furthest left would be the negative one. So the negative 5 over 2 would come first, cross it off. Then I would get to 0. Then would be the 0.5, 129. And then the 0.6 repeating would be the next biggest. And finally, the square root of 2, because it's 1.41, the square root of 2 would be the last one in the list. You can try 2b on your own. And next we'll talk about finite versus infinite sets. Depending on the list you have, a set of numbers is really just a list when you see that in math, so it's a list. A finite set has an end to the list, so you can start and end your list. There's a certain number of numbers in it. An infinite set, you can never stop naming the numbers in the list. So this is a list that goes on forever. So the first way we represent sets is with roster notation, and you're probably pretty familiar with this already, but you just list the elements in the list inside braces and you separate them by a comma, like a class list or the alphabet. It's a finite set. You can count how many things are in it. So if we were to represent billiard balls, we'd put our bracket, put 1, 2, 3, 4, 5, all the way up. I can write faster than my pen can keep up with me. And then we make sure to close the bracket at the end so people know we're done writing our list. The next way we represent sets is using a number line. So let's just real quick remember our symbols. The ones that point to the left are the ones that look like a squished L. Those are the less than signs. The ones that are pointing to the right, those are greater than signs. And we put closed circles when there's an equal sign underneath, and an open circle when there's an open space underneath or no equal sign when we graph them. So closed circle because of the equal sign, open circle because there's no line underneath. So to graph this inequality, this says all the numbers that are less than or equal to 4. Well, there's an infinite number of numbers that are less than or equal to 4. So I'll put 4, 5, and 3 on the number line. I'm going to put a filled in circle on 4 because there is the equal sign underneath. And all the numbers to the left of 4, those are all less than 4. By shading the number line, we're showing that we mean every single number, not just 3, 2, 1, and 0, but all these decimals in between. Those are all numbers less than or equal to 4. To go the opposite way, to go from the number line to the inequality, I have a fast way to teach you how to write these. All we need is the lowest number and the highest number and leave a space in between. We're talking about the numbers in between them, so rather than write all the numbers that are in between them, we're going to write an X. And because we wrote our numbers from low to high, we always can have our signs pointing to the left, or the less than signs. Then we just have to figure out if we need the equal sign. Since that's an open circle, we do not need the equal sign. And since that is an open circle, we do not need the equal sign there. And that's it. To verify that this works, if you look at each side, is X greater than 3? Is the shaded part on the large side of 3? Yes. And if you look at the other side, if you look at this part of it, is X on the small side of 5? Is it less than 5? Yeah. But you can just remember the low number, the high number. You always put the X in the middle, and you always put the signs pointing to the left. Interval notation you haven't seen before, but it goes right along with those inequality signs. If you have just less than signs, or if you have open circles, we're going to use parentheses. And if you have less than or equal or greater than or equal to symbols or closed circles, we're going to use these straight brackets. So all we need is the lowest number, then a comma, and then the highest number. So I'm going to take the 4, put a comma, put the 100, and now I just look at these symbols to see what kind of parenthesis or bracket I use. Since this is just less than, that matches up with the curly parenthesis. the curved one. And since this is less than or equal to, the equal to signs go with the straight ones. So that's a straight bracket. On the next example, I'm going to put the lowest number, 0, a comma in the highest number, and then I look at these endpoints. This is filled in, so that's like an equal sign, so I use a straight bracket here. This circle is open. The open circle goes with the curved parenthesis. The last type of notation is set builder. This combines inequalities with the types of sets, the abbreviation of the set. So your job when you fill out set builder is to copy everything down but fill in the correct inequality and fill out the proper abbreviation for the set of numbers. So here's what I mean by that. This is a sentence where you always write this bracket in the X and then this bar. When you read it, it means the set of all X's such that, and then it fits in this inequality, and then you say X is an element of, that little backwards E is the word element, or it's contained in the set, and then you have to fill in whatever set of numbers your numbers are in, and then you close it with that bracket. So I've written that kind of skeleton for you. It's the set of all X's such that, let's look at the numbers we're talking about here. Integers between 0 and 8, so I have to write the inequality here. So 0 is my low number, 8 is my high number. The numbers are in between, so I put an X. I always put less than signs, and it says inclusive. That means we include the 0 and we include the 8. And X is an element of the integers. So we need to put the symbol for integers right here because that's the set. So the symbol for integers is Z. I could write it in set builder. If I were to do a number line, this would look like a 0, a 1, a 2, a 3. We're just talking about the integers, so we don't have any decimals. It would be just the actual numbers, 6, 7, 8. So that's what it would mean if it looked like a number line, but we're just using set builder. It's in between 0 and 8, including them, and your numbers are integers. If you wanted all real numbers, if this was an R, then you would just shade the number line in and connect the 0 and the 8. Let's try one last one. We have the set of all numbers, X, such that. Now we need to take this and write it as an inequality. So I'm going to write, the inequality always goes right here. The 0 is the low number, the 4 is the high number, X goes in the middle, signs always point to the left. This sign is filled in, so it gets an equal sign. This circle is open, so I leave it blank. Since these are connected and they mean every single number in between 0 and 4, we mean all the real numbers.